Hi everyone. Linear programming is the topic we're working on, and it is a way of finding a maximum or minimum value of a bounded region when we're dealing with linear inequalities. And we've graphed those earlier, and we're going to work with that a little more. The idea here is that the vertices provide either maximum or minimum values of our bounded regions. Now a farmer, let's look at the first example. This is a agrarian example. A farmer has 10 acres to plant in wheat and rye. He has to plant at least 7 acres. However, he only has $1,200 to spend on each acre, and each acre of wheat costs $200 to plant, and each acre of rye costs $100 to plant. Moreover, the farmer has to get the planting done in 12 hours, and it takes 1 hour, it says an hour, but that's 1 hour to plant an acre of wheat and 2 hours to plant an acre of rye. If the profit is $500 per acre of wheat and $300 per acre of rye, how many acres of each should be planted to maximize profits? All right, we got lots of information there. Let's first of all define our variables, and let's use W for the number of acres of wheat, and let's use R to equal the number of acres of rye that we want to plant. And the farmer has 10 acres that he can plant. So if I add the number of acres of wheat plus the number of acres of rye, he has 10, so I'm going to make that less than or equal to 10. He can plant up to 10 acres, but he has to plant at least 7. So let's put W plus R has to be at least 7 acres. So I've got 2 constraints here so far, 2 inequalities. The next sentence says he has only $1,200 to spend on each acre of wheat, and each acre of wheat costs $200 to plant, and each acre of rye costs $100. So as far as money goes, he has $200 times W for planting the wheat, and he has 100 times R for planting the rye, and he has to keep that at $1,200 or less. That's all the money he has to do that. Now he also has a time factor here. The farmer has to get the planting done in 12 hours. And it takes 1 hour, so 1 times the number of acres of wheat plus 2 times the number of acres of rye, 2 hours for each rye, that has to be done in 12 hours or less. Okay, so we have all sorts of constraints here. We have 4 constraints. And we also have a profit function we need to. The profit, where W is the number of acres of wheat and R is the number of acres of rye, is 500 W plus 300 R. Now the job now is to figure out what this boundary looks like. So we have 4 inequalities here, and I'm going to let this be my W axis, and it's for the number of acres of wheat, and I'm going to number them. And I'm going to let this be my R axis, and R is the number of acres of rye, and I'm going to number that. I'm only going to go up to 10 because that's how much, go up to 10 because that's how many acres we have. We can't go past that in what we are doing. Now, It is time to graph each inequality individually. And the first one, W plus R, is less than or equal to 10. Okay, W plus R equals 10 is the boundary line. If W is 0, if we planted no wheat, we would plant 10 acres of rye. And if we planted no rye, we would plant 10 acres of wheat. So what I want to do is put 0, 10 and 10, 0 on here. And I want to carefully graph that. Joey and Caleb provided my straight edge. This is your pass you gave me. And we want to stay, we have to stay under that. Okay, so I'm going to shade lightly because I've got 4 constraints, remember. Now also consider that W plus R is greater than or equal to 7. That we've got to plant at least 7 acres. And again, I'm looking at if it was only wheat, we'd plant 7 acres of rye. If there's no wheat, you'd plant 7 acres of rye. If there was no rye, you'd plant 7 acres of wheat. So I'm going to connect 0, 7 and 7, 0. And that inequality goes the other direction. So let me draw carefully. That inequality. And that's greater than 7. This is the 7 line. You know, like 4, 3, 3, 4, 2, 5, 1, 6. Now, I'm going to stay. So we got this band for the number of acres we can plant of each. The next constraint is 200W plus 100R is less than or equal to 1200. If I plant no wheat, I could plant up to 12 acres, 1200 divided by 100. 100 times 12 is 1200. I could plant 12 acres of rye. Now I know that is not a value, but we're still going to use it for our graphing. I know that's not in our amount that we could plant, but it's still a point that will help us get the line we need. If I plant no rye, only wheat, no rye, I have 200 times 6 is 1200. So 0, 12. Here's 10, here's 11, here's 12. 0, 12. I'm going to connect that with 6, 0. And I've got to stay under that line. Okay, so let's draw this. Okay, I'm being very deliberate. So I'm under this line. So right now, everything that's under this line and between in this band is right here for now. But we have one more constraint, and that involves the W and 2R. Again, if we planted only wheat, if we planted no wheat and only rye, we would have 6 hours to get the rye done. If we planted, we could do 6 hours of rye. 6 acres of rye. 2 times 6 is 12. If we have only rye, and we planted no rye, and we planted all wheat, we would have 12 acres. So I'm going to connect 0, 6, and I got to go out to 11 and 12 here. I'm going to connect those two, and I've got to stay under that line in my solution. Let's line that up nicely. So I got to stay under this line. Okay, now my whole region now, I've got to stay under this line. I'm bounded by this this under this line, but I also have to stay under this line, and I got to be inside the band, and this. Okay, now we have enough information here for this problem. What I need you to see is that our vertices of this region, this is the region that satisfies all four constraints here. 2 acres of wheat right here, and 5 acres of rye. This is the R-axis. Right here, that is 4 acres of wheat and 4 acres of rye. And right here, that is 5 acres of wheat and 2 acres of rye. So for each one, I'm going to go with the profit function now. W is 2, R is 5. I take 500 times 2 plus 300 times 5, and I get 1,000 plus 1,500 is $2,500. If I planted 2 acres of wheat and 5 acres of rye, I would make $2,500. If I planted 4 acres of wheat and 4 acres of rye, that's 2,000. That's 1,200. That is $3,200. That's the profit I would make there. And if I planted 5 acres of wheat and 2 acres of rye, I'd make 500 times 5 and 300 times 2. The only possibilities are these 3 vertices, are the vertices of the shaded region, of the feasible region. And that is 2,500, and that is 300 times 2 is 600. So that profit would give me $3,100. We are going to make the most money, given all our time constraints and the amount we have to spend on our seed and everything. We are going to make the most money from this function, this point right here. So if we plant 4 acres of wheat and 4 acres of rye, we will make our maximum profit of $3,200. Nothing else that follows all these constraints here will yield us more than $3,200. One of these points was going to give us the maximum. All right, so understand, you get all of your constraints written down, you figure out what your function is that you're trying to maximize or minimize. It's a 2-variable function. You plot all your inequalities, you look for the region that is shaded, and these points that are at the vertices, this is a triangle, these 3 points are your either maximum or minimum values that you can make in profit. And you just try them all and figure out which one works for you the best. Okay, we'll see you later.